Greetings, my beloved viewers. I'm Mr. Okafor PC, your online physics teacher. I know some of us may have phobia for physics, but this platform is here to make physics simple. It targets to demystify the mysteries of physics. Our topic of interest today is Introduction to Physics. But before we delve into the topic, there is a question that has bugged generations of mankind, and the question is, who are we? Who are we? This simple question led to diverse disciplines that we study around the universities of the world. We have School of Sciences, School of Arts, School of Humanities, School of Languages. All these schools of interests target to answer the question, who are we? So we'll be narrowing it down to the School of Sciences. In the School of Sciences, there is a discipline, a pure science discipline by name physics. And that's our topic of interest today, Intro to Physics. So we'll start this way. To answer the question, who are we in the discipline of physics? We'll say, how did physics originate? Physics originated from a Greek word, physikos. Physikos simply means relating to nature. Physics is saying that we are our environments. Where we stay is where we are. Who are we? We are our environment. So physics has interest in the nature, in the nearest environment and the farthest environment. So physics is a pure science subject that studies our natural world. It looks into nature to see things in nature, and we call those things matters. Physics also looks deep to see the energy in them. Physics sees why they are where they are. Physics sees the forces moving them. Physics sees the changes that happen to them with respect to time. Therefore, in summary, physics is a pure science subject that studies the motion, the forces, and the interactions in matter, and the changes that happen to matter with respect to time. So one may ask, what do we need the motion of things around us to do? What do we do with them? Of what importance is them? Or the motions of matters around us? It's of paramount importance there. It's because of the motion of the earth that we have seasons of the earth. It's because of the motion of the earth that we have day and night. It's because of the motion of the moon around the earth that we have moons. And to shock you the most, it's because of the motion of the earth that we have survival in the earth's surface. Our existence is attributed to the motion of the earth. If the earth wasn't moving at its speed, at earth speed, around the orbit of the sun, the earth would have collapsed inside the sun. So the movement of the earth makes it possible for the earth to escape the gravitational pull of the sun. If not for the motion of the earth would have sunk into the sun and our existence would go into extinction. So the motion of things around us is of paramount importance to scientists. The next topic of interest in understanding physics better is scientific method. So if physics is a subject or a discipline or a study area, it must have tactics deployed to get to the answer to the question, who are we? So physics targets the truth. In order to get this truth, we don't run into conclusion, because anything called truths in the scientific world must go through a rigorous process before you can say this is true or this is truth. So in order to observe that, to get to a better answer to the questions that revolve around the scientific world, we must undergo scientific methods. And the methods include observation is the first. Every scientist must have a skill in observation. You must learn to make a kind of thorough study of objects or matters around you. Careful study of them. And that is called observation. And the second is questioning. When you observe things around you, you must have that intelligence to question. You must be able to ask questions based on observation. Now take us to the third one, hypothesis. When you ask questions, you must also have the intelligence to provide answers to your questions. Answers. But this answer is not yet the ultimate. It's not the ending. And it's not the truth we are looking for. It's just early conclusion. Early. I didn't say final conclusion. So it's an early conclusion to your own question. Hypothesis is a smart guess, an intelligent guess. When you make hypothesis, then get it ready to undergo the most thorough scientific method, and that is experiments. Experimentation is the beauty of scientific method. There is no scientific method in the absence of experiments. And the father of experiment is Galileo Galilei. Galileo Galilei argued that for anything to be considered truth in the world of science, it must undergo experimentation. It must pass through the crucibles of experiments. Otherwise, it's not a scientific fact or truth. Take, for instance, in the ancient world, there is a scholar by name Aristotle. Aristotle is a notable scholar that his ideas endures more than 2,000 years. But most of his ideas collapsed in the time of Galileo, who noticed that the best crucible to tell us what truth in the natural world is experiments. Okay, what's the emphasis here? Aristotle argued that when you get two bodies of different masses, example, a stone and a feather, and get them to the same height, release them at the same time, that the stone reaches the earth or the ground before the feather. That a denser or a massive body falls to the ground before the less dense or the less massive body gets to the ground. And by common reasoning, this is true. But in the crucible, in the scientific method, it is not actually true because experiment defies that. Galileo has proven that when you get two bodies of different masses at the same height and release them at the same time, that both of them reach the ground at the same time, irrespective of their different masses. And this is what experiment promotes in the natural world. So the truth is this, that two bodies of different masses, a rock, a stone, and a feather, irrespective of their masses, provided they are falling down at the same time from the same height, they will reach the ground at the same time. Because the earth exerts the same force on all bodies, irrespective of the masses. So when we delve into physics, the more you tend to appreciate better what we're saying, and tend to appreciate better the beauty of nature. So experiment is key to scientific truths. So it is not only based on observation, questioning, hypothesis, it must undergo a thorough process called experiment, because that is what nature approves. So in the study of nature, nature makes the final decision. It's not left us to conclude on our mere observation. Those observations can be confused. Like Aristotle was confused. He thought that is how it would have happened because it is a denser body, should get to the ground first. But nature does not permit that. Nature permits that all bodies, irrespective of their masses, coming from the same height, reaches the ground at the same time. So today we know that masses of particles around us, when it comes to falling down, they are not a factor to the falling of the bodies. Falling of bodies is independent of their masses. Provided they fall from the same height, they reach the ground at the same time. Thank God for experiment, and thank God for Galileo Galilei. And ever since then, the key scientific method is experiments. Then after experiment is the next method called inference. When you make experiments, are you able to connect that experiment to the final truth? Inference. Can you infer the truth from the experiment, then now land yourself in the conclusion, the last scientific method? Therefore, we have 6 scientific methods: observation, questioning, hypothesis, experiments, inference, and conclusion. Let's just make a little emphasis of this scientific method once again. Let's say we have a mother who has a baby, and the mother happens to be doing house show. Then it didn't take a long while. The baby begins to cry. So the mother can easily say, my baby is crying because my baby is hungry. This is what you see in art. Immediate conclusion. Art is imaginative subjects. It's concerned with you deploying your mental skill to answer the possible reactions you get from your environment. So in art, we're more concerned with the beauty of the thinking thoughts, the thinking processes. We're not actually concerned with the truth. We want to see how imaginative you are. So it's obtainable in the world of art that a mother can easily say, my baby is crying because my baby is hungry. But it's not obtainable in the world of science. In the world of science, we want to answer, why is the baby crying? Because when we know why the baby is crying, we can stop the baby from crying. The baby cries no more. So see what the mother will do as a science scholar. The mother will first of all observe the baby. When the mother observes the baby, the mother may notice that the baby moves the legs more than every other body parts. So the mother begins to wonder, why is the baby moving the legs more? That is questioning that followed observation. So the mother wonders, is there any other body part that the baby is moving? Any other body part? So the mother notices that other body parts are moving. but the legs are being moved more. So the mother comes up with hypothesis. Is it that something has beaten my baby? The mother tries to answer the question, the movement of the legs. What could be the possible reason for it? The mother says, is it likely that something has beaten my baby on the leg? Is it likely that my baby is hungry? Is it likely that my baby has wet diapers? So these are hypotheses. S-I-X at the ending is singular. S-E-S at the ending is plural. So these are hypotheses. The mother has 3 hypotheses at this point. Maybe something has beaten the baby. Maybe the baby is hungry. Maybe the baby has wet diapers. Then the mother has not got to the truth yet. The mother is just making intelligent guesses. So the mother will now undergo through the rigorous process in science called experimentation. The mother gets close to the baby, puts hands on deck. The mother lays hands on the baby. The mother even lays hands on her breast, take it towards the baby's mouth. So the baby sucks the breast for a while and gets it aside and begins to cry again. That means the baby needs the food, but the food is not the cause of the problem at the moment. The baby is crying because of something else. So the mother understands that the baby is not actually hungry. So the mother goes again. The mother takes the baby's leg to see if there is any wound or any mark that will indicate something has beaten the baby. So when the mother fails to see, the mother goes to the next stage. The mother now goes to the baby's diapers to open it. And the mother may be fortunate enough to notice that the baby has wet the diapers. So the mother changes the diapers. The mother gets a new one, cleans the baby, and puts the new one on the baby. So after some while, the baby stops crying. So the mother can now inference. My baby was crying because the diapers was wet. So the mother will now conclude that anytime my baby's diapers gets wet, my baby begins to cry. So what would the mother do? The mother will get enough diapers in order to respond to that reaction. So the mother now knows that one of the reasons that can make the baby to cry is wet diapers. And the mother has seen the baby stop crying. So the mother concludes that what made the baby to cry was wet diapers. And this is a science scholar. So you put actual solution to problem. So the mother has seen the truths. And this is the beauty of scientific method. We don't just run to conclusion. No, as science scholars, we are perfect, we are tactical, we know how best to manage issues. And this is why the rest of the world don't joke with science truths or science facts. When we say something is scientific, they know that it is reliable and valid. Thank you. As we go on this platform, we expose you to science, science findings, science skills, and so many things that will help you in the study of physics and make you a master in the field of physics. Thank you, and remain with us. Please do subscribe. Thank you very much.